continue on lesson 1.2, and we really have the same learning goal as we had yesterday. I can solve one-step equations. In other words, there should be one step of work involved in one variable. In other words, there's only going to be one variable in the whole problem, and using addition or subtraction. Okay? So, objective, we're going to look at example 2. So what we're going to practice right now are problems like example 2. What is the objective in example 2? Preston?
Solving equations by using subtraction.
Solving equations by using subtraction. Oops, that's not where I want that to be. Sorry. I want it to be right here. Solving equations using subtraction. Solving equations using subtraction. Which operation does subtraction undo? Addition, right? Subtraction undoes addition. So if we're going to use subtraction to solve, that means we must have some addition to undo. So we need to get the variable alone, we need to use subtraction to undo the addition that's going on in the equation. So we're at about the middle of the page, the check it out problem. Solve each equation, check your answer. How many problems are there for us to work? 3 of them. They are what? 2. Find them in your book for me. Find them. 2. So halfway down the page, page 18, below example 2. Some of you are letting the rest of us do the work for you. How many equations do we have to solve again, class?
3.
3. They are 2A, 2B, 2C. Okay. I just happened to write the first one down for you. It is D plus 1/2 equals 1. Okay. I have a line here showing that we're dividing both sides of the equation into sides. It's kind of like so we can play fair, keep it balanced. D plus 1/2 equals 1. What do we have to do to get D alone in this one? Preston?
Subtract the 1/2 on the other.
Where do we have to subtract 1/2?
To the ones.
On both sides. On both sides. Just like if you took one circle off on our exploration, on one side we took a circle off on the other. We didn't just do it on one side. It's not going to stay balanced if that's what we do. So now we do have the D by itself because the subtracting 1/2 undid the adding 1/2. It's gone. It's like somebody giving you 50 cents and then taking it back again. That's what just happened on that side. What's 1 take away 1/2? I don't think we need to change 1 into a fraction because this is one I think we know. What's 1 take away 1/2? 0.5. 1/2. We're kind of working with fractions, so maybe we could just leave it as a fraction, right? 1/2. If you had to take 1/2 away from 1, you still have the other 1/2 left, right? Okay, so here's our solution. We're going to circle box something to make that stand out because now we're also going to do a check problem. Okay. We've got lots of people who need to really tune in right now because check problems did not go so well for the majority of us in here. We do it in a kind of like this T-table thing. We write the equation down, we draw a line underneath it, and coming down from the equal sign we have another line. Now we're going to substitute in place of the D. What are we going to put in place of it? 1/2. What we think D is equal to. And then we bring down the rest of it because there's no replacing to do for the rest of it. So this is what we call our substitution step. Would you write that in your notes, please? You do not have to write these words when you're doing your homework, but you need to understand that when you're doing a check problem, you're substituting back in what you think the solution is. But we're not done yet. We're not solving, we're evaluating. So on that left side, we have 1/2 plus 1/2. What is 1/2 plus 1/2? 1. Because it really is, or because we want it to be? Because it really is, yeah. So this becomes 1, equals is going to stay equals, 1 is 1, we'll leave that as a 1, there's nothing to do with it. Now we can say it checks. So there's 3 lines in our check box. The equation with the variable in it, the substitution step, and the final, you know what, this is an equality, this is true. So questions about any part of that? No? Okay, then let's copy down the equation. Go ahead from your book. Copy down the next equation we have to solve, 2b. Make sure I copy this down right too. Don't be just trusting that I wrote it down right. This is the one from the book. Let me know. We have it right. Okay, so I'm going to draw my line down from the equal sign that says, you know what, there's 2 sides to this equation. One side is the same as the other, so I have to do the same thing to both sides. So it's, what do we need to isolate here? What needs to be by itself? The k. So right now, what is being added to k? 5 is being added to k, so what are we going to do? We need to subtract 5. So we subtract 5 here because we're trying to undo that addition. But if we do it there, we also got to come over here and do it. We're not going to use our calculators right now. We're going to process through this and see what negative 5 take away 5 is. So what is negative 5? So it's like it's 5 degrees below 0. Subtract 5, it's kind of like saying it drops another 5 degrees. Negative 10. Yeah, that actually ends up at negative 10. Here's another thing that we're going to commonly do. We can change subtraction to add the opposite. Did you do that in prior math classes at all? Change subtraction to add the opposite? Did that happen anywhere in anybody's math world? No?
Just yesterday.
Just yesterday? Oh, you must be working with Mrs. Protestant, huh? Yeah. Love that. Okay, here's what we do with subtraction. Because we're going to try to work with our calculators as much as we possibly can. Whenever we have a subtraction going on, this is a negative sign. This is negative 5, subtract 10. We're going to change this to, oh, no, I did that wrong. Sorry. That's my mistake. I am looking at the answer here and doing it with that. So let's go back here. So I'm just going to erase that answer so it's not there for a minute so you can see what I'm doing. We're going to change, this is negative 5, subtract 5. We're going to change this to add. The subtraction is going to become add, but now 5 has to become its opposite. What's the opposite of 5? Or in other words, which numbers on the other side of 0, the same distance away? Negative 5. This is going to become a negative 5. So negative 5 is the same distance from 0 on the number line. They are called opposites of each other. So when we change subtraction to add the opposite, we say 5 was being subtracted. We're changing it to add, so the opposite of 5 is negative 5. Now, we need to use the rules. What happens when you add 2 negatives? You got a negative 5 and another negative 5. What happens when you add negatives? Does it go positive or does it stay negative? It stays negative, doesn't it? You can't borrow $5 from somebody and borrow another $5 from somebody and all of a sudden you've got, they say to you, oh, here, have another 10. You don't owe me anything. That doesn't happen. You have the $10 you borrowed, but you still owe them $10, don't you? A negative 10. So this is, when we multiply negatives, what happens? Then they become positive, but we're adding negatives. The temperature drops again, it can't end up above 0. It just can't happen when the temperature keeps going down. So this becomes negative 10 equals K. There's our solution. But now we need to do a check problem. So I'll come over here and do it. I don't know how much room I allowed. So it's the first thing we do in a check problem. First step. Remember, it's a 3-line check problem. What's the first line? Put the original problem down. Put the original equation before it got solved. What do we do with that? Draw a line under it. Another line coming down from the equal sign. And now we do a substitution step, right? So -5 doesn't, we don't substitute anything for that. We don't substitute anything for the equal sign. We substitute a -10 for the k. We don't substitute anything for the addition sign, and we don't substitute anything for 5. So that's our substitution step. Are we done? No, what do we have to do? We have to finish evaluating. That's what we're doing on this right side. So -10 plus 5. Okay. Help convince me that it's -5. Not because the other side is -5, but why is -10 plus 5 -5? Convince me. Blake? Well, so whenever you add a positive to a negative, you'll always get a negative. Okay, I'm not convinced quite yet.
Subtract 10 from, yeah.
Okay, I got lots of people in here who are thinking this through right now. Tell me why -10 plus 5 becomes -5. Give it an example of something in real life that says, this helps me understand it. Adam?
Okay, yeah, so if you're going from -10, that means adding, you go back when it's a negative, right?
So we're starting at -10, aren't we?
Yeah.
And then we're adding 5. So which direction will we go to add 5? Joseph, we go to the left. If we're adding 5. If we're adding -5, remember negative means left, positive means right. So we need to go this direction 5, and we will end up at -5. Okay? Now give me a real life thing. Come on, let's put in perspective of something in real life.
It's like you owe somebody $10, you give them $5,
So you're in the hole $10. You owe somebody $10. Friend, you walk up to your friend like, hey, do you remember you owe me $10? And you get in your pocket and Blake says all you have is 5, so you take that 5 out and you go, okay, here's 5. Now how much do you owe? $5. But when you owe, is it a -5? Yeah, it's a negative, isn't it? Okay, so there's a real life example. Do you make one with another one? But we need to be able to do these things without the calculator. Why is the answer what it is? Not just because the calculator proves it is. Good. I love when you don't use your calculators. You know what, we live in North Dakota. Is it ever going to be cold here?
Yes. Oh, Celsius.
It's going to be below 0, is it not? So the morning starts out, you're walking to school, and your brother says to you, or your sister, or your mom, or somebody says to you, seriously? You're not going to put a hat on? It's 10 below 0. And you're like, well, I heard it's going to warm up 5 degrees. So I don't need a hat. So what happens when it warms up 5 degrees? Now where's the temperature at? -5, yeah. We've got closer to 0, didn't it? It's starting to climb, it's getting closer to 0. Eventually this hopefully will be above 0. So again, I'm not going to just let you come up with answers. I want you to know why it works the way it does. Write down the equation for 2C, our last one that we need to do.
We actually have to make that -5 equals like
Oh, we're not done. Good job, Blake. Blake caught me. We weren't finished yet. -5 equals -10 plus 5. We've decided over and over again it is -5, and yes, it checks. So we want to make sure it is, though, before we put it down. And we made real sure, didn't we? Okay, now let's write down. Thank you, Blake, for catching that for me. Let's write down our last equation that we're actually going to solve here. Unless there's something on the back. Okay, notice what variable they used. What variable did they use? T. And what is a T? What could that vary easily be mistaken for?
Plus
A plus sign. So what you want to do is you want to try to make your T some way that it's not going to look like a plus sign. Like I like to write mine cursive, like with curvies. Okay? Okay, now we're going to solve this. So we're going to say, I need to do something to get T alone. What are we going to do? Class, what are we going to do? Subtract 6, okay? So we come over here and subtract 6, and we subtract 6. Why did we subtract 6?
But you were adding 6.
Yeah, can we read addition backwards? In other words, could this be renamed as T plus 6 equals 14? Could we rename it like that? Is that okay? Is that legitimate to take the 6 plus T and rename it as T plus 6? Can't you do that in addition? Is 6 plus 3 the same as 3 plus 6? Yeah. So these two can trade places, and we can say, oh yeah, 6 is being added, so we need to...
Can I get Catherine Beaver, Brooklyn Trevo, and Jade Olson to my office, or junior office, please?
So now T is by itself. Anybody in here happen to know what 14 take away 6 is?
8.
8. Okay. That is our what? What did we just find? Solution. That's our solution. So now we need to check. Okay. So when we do a check problem, we write down the original equation. What's that next step called? Substitution step. Because what we're doing is we're saying, it's kind of like we just ignore this other side of the equation. We have the algebraic expression 6 plus t. We're evaluating it. We're saying when t equals 8. So that we're checking it out to see if 8 will make the whole equation true, right? Now, I don't even want you to look at that other side. I want you to look at this side only, and I want you to say, what is 6 plus 8? 14. Really? For sure? You're convinced it really is? Okay, then that's what we'll put. We'll bring down our equal sign. The other side has a 14. We can say it checks. Now, students love to just put what it's supposed to be, and they don't even really try and make sure that it does check out. So that's what I say to you. Are you sure? Are you, is it because we want it to be or because it really is? Any questions?